G'day, all you people in England and where else. The actual Rover motor we're using here is the latest model that I think they made. It was a cross bolt, and it was, I think the prefix on the casting number was LCR, which is right up to the last ones that they ever produced. I think you call it a 4-block. I'm not real sure. Maybe somebody can fill that in. That's a distributor out of a 1962 model Buick. We use that, like I said before, is because we can get all the internals for the MSD and convert it all over to CDI. We don't run a water pump. We run an electric water pump, which is down here, and that seems to be a good idea because we're just running out of room in the front of the engine. The actual tapper covers are the later model 4.6 4-litre. There we obviously weld up holes. We grind all the internals out of it so we can fit the roller rockers. The actual roller rockers, a Yellow Terror, Australian made, and they're called Ultra Race, something like that. They're full roller on the shafts and on the tips. We do have to modify them a fair bit because we use the double valve springs, non-interference fit. We use one-piece valves, heavy-duty stainless steel. They are the same size as the original ones. Well, there might be half a mil difference in them. We do that because otherwise, if you put bigger valves in them, you're going to start notching the top of the bores, and you get into a lot more interference problems. So we steered away from that and just left them standard. It's pretty well as big as you want to go, and with the performance we're getting out of it, I don't think it warrants putting bigger valves in for the 6250 revs we put it on. We don't go over 6250 with a rev limiter. We use inside. We use chrome moly adjustable, custom-made push rods. We use, in this particular motor, which I don't normally do, we've run solid lifters. They're Johnson EDM with the holes in the bottom of them to help lubricate between the face of the lifter and the camshaft. It is quite an aggressive camshaft, I must admit, but we've actually changed cams a few times because one of the cams we had way too much torque. It kept breaking loose. We went for the up end rather than the upper end of the rev range, rather than start trying to chunk out huge amounts of torque down low. The heads, which we will show you later, and the inlet manifold, Edelbrock, the heads are actually SD1 Rover because this was built a long while ago. We could still get them, and they seem to me to have more casting inside them. It has the provision for the inlets for the pipes to let the air pumps, when they were mucking around with that 27A emission controls in Australia. They don't have the actual holes in there. Thus, they still have the extra casting, which I think gives you that little bit more to play with or to grind out. As I said, the bottom end is the LCR, I think they call it, which is the last of the blocks where the liners don't fall out of them. We buy the pistons from Marl, and they're finished, but not to what we want. So we take all the flashing off the inside, and we take a little bit off the skirt. We put our own valve reliefs in, obviously, and lighten them up as much as we possibly can. We use the standard, the pistons are, as I said, a Marl, and they're hypoelectric, and they seem to be hanging in there. They're pretty good. I like to run as long a skirt on them as I can possibly get for stability and ring seal. The top ring in this particular motor is we've machined it out. We put a 2mm top ring, nodular cast iron. We use the Napier second ring, which is a 1.75, and the 3-piece Repco 3X oil control ring, the 3-piece one, which I think Repco first designed that many years ago in the early 60s. That's the bottom oil ring we use. The rods are standard 4.6 litre rods, the later model BMW, when BMW owned it. We grind them down from about 780, sand them down, lighten them, call it what you want, shot peen and hardened, resize them, and we get them down to 569 grams. The actual gudgeon pins, we've changed them over because they were very heavy, because they were for mile pistons. They were just too heavy. And I put a good set of JW LS Chev gudgeon pins in it. We use the old style clearances on the big end and main bearings, which is, I like to run about 1.8 on the big ends and 2.2 to 2.3 on the mains, maybe 2.5. The exhaust manifolds are P6B Rover manuals, which were slightly larger on the inside, plus we absolutely grind the guts out of them, and the cylinder heads and the air net manifold, because nothing matches. And I think if you treat the engine as an air pump, you're going to achieve the things that you want. Just treat it like an air pump, open all the ports out as far as you possibly can without grinding into oblivion. We use a phenolic spacer, a 600 double pumper Rover polycarby, which seems to work really well. I tried a 650 and it just bogged. Didn't produce the drivability as the normal type 600. So we went away from the 650 HP. I think that's pretty well. On the other video, we did explain the oiling system, so I won't bother going back over that again. I'll take you back down into the workshop, and we'll have a look at the cylinder heads that I have done and I am doing. This is the later model one out of the MAs and all the cross bolts. The head over here is a SD1 Rover. We don't use those anymore, the SD1s. We've gone on back over to here because of just availability, and they're all in better condition, and they're just a better head and better cast as far as I'm concerned. As you can see by the exhaust ports, and the inlets are no different, we actually do an extensive port job to make them as big as we possibly can, and not run into problems with push rods or anything like that. But it seems to work, and the motors do go very, very well. As far as the combustion chamber is concerned, we try not to, we take all the sharp edges of it, obviously. We leave the valve sizes the same, as I indicated before. This one here had all the squish taken out of it. As you can see by the line on this one, we incorporate all the squish back in it. We had too much compression before at one stage there. These are the pistons that we're using. As I said, they're male. The gudgeon pin's heavy as. We changed that to a JW LS lightweight tool steel gudgeon. The top ring we take out to 2. The middle one's 175, and the bottom ring's 3mm, 3-piece Repco 3X. Now the top of the piston, as you can see, and we did consult and have a lot of conversations with Jack Brabham when he did all his, and he said he'd try and turn the combustion chamber into a heron head. try and put as much of the combustion chamber inside the piston. This is a piston that's straight out of the box with the gudgeon pin and everything in it. We do put valve reliefs in the top of the piston with a tool we've got in situ. When we put the cylinder head on, we just cut them. We do take a bit more out here to get the compression where we want it. We leave the squish or the internal charge motion on here around the side as much as we can. We relieve the side here as much as we can to get the laminar flow. Jack said, concentrate on laminar flow. Don't worry about swirl or tumble. Just do laminar flow. That will get you where you want to go. This is the MG we built for a gentleman. He wanted something that just go out, start it. It's got a holly on it, very similar to the P6. Because everything's electrical, we put a decent sized Jaguar V8 130 amp Nippon Denso alternator. It's got an electric water pump, as you can see. It fits down just in front of the front wheel down in the inner mudguard. The distributor is out of a Land Rover CDI with MSD inside the actual cab, away from the heat. In regards to the exhaust, we wrapped it, cut a hole in the guards and put it down through there to try and keep some of the heat out of it. And a good set of leads that you can't cook. The oiling system is, we've used the Girota pump, which is out of the, I think it's a Series 2 Land Rover. And it doesn't run off the distributor drive, which I think is an absolute disaster. We saw the whole oil filter arrangement off the bottom of the timing cover, weld up all the holes that are left, re-drill more holes from the side here, from the side on, as to miss the steering rack, because it is very snug. They're never meant to have a Rover V8 in them. And as you can see, the rest of what we've done as far as engine mounts, we've put engine stays in, like we do to all our cars, and then wind them down onto the engine mounts so they just don't constantly break engine mounts. There is another one of those underneath the alternator on the other side. As far as the cooling system is concerned, there is that front cross member. We actually cut it out and put another thicker, more robust one in with a plate that runs down to the front here, is to strengthen the whole front of the car. We actually move that cross member forward, I'd say about that far, is to facilitate getting that PWR radiator in. We've moved the oil cooler to under the engine, as you can see from here. That's another PWR piece of art. They build the best radiators and the best oil coolers in the world, as far as I'm concerned. It's thermostatically controlled with the 16-inch spower fan. Once it comes on at 75 degrees, it usually, or 73 degrees, it'll cut back off at 69. All our aluminium engines run on 70 degrees Celsius and no more. You want to go to 90, you lose power. The more efficient you have your combustion chamber, the less heat you need inside the engine to actually get complete combustion. Don't let anybody ever tell you any different. These aluminium motors, the same as the new V8 supercars and the Chevs, run at 70 degrees Celsius. And we've been doing this now for 40 years.